All right, ladies and gentlemen, boys and girls, welcome. Today we're going to talk a little bit about the scientific process. But before we talk about that, I want to just talk about this being the first video of us doing kind of remote learning and you guys taking notes on it. I just want to remind you about the process of taking good notes. First of all, you should have your notebooks out, all right, and in front of you. The nice thing about a video is that you can stop me at any point, all right? So I'm going to write things on the board. All right, I like doing it because it paces me out as well, makes me feel interactive, like I'm doing things as well. But just because I write something on the board doesn't necessarily need to be go in your notebook. But more importantly, just because I don't write something on the board doesn't mean it shouldn't go in your notebook. For example, we're going to talk a little bit about variables today. If I say variables and I just write variables, and then I talk about them, I might not write an actual definition here, but if I'm talking about the variable and you feel like it's valuable, then you need to write it down in your notebook. And the nice thing is if I'm going too fast, pause me. Or you're like, oh, by the time I wrote variable in my notebook, he was already talking about it, go back. All right, so let's be smart about how we're taking notes. Take your time. These notes are for you, all right? So it's a little bit different, so you're going to have to change your game a little bit and do it a little bit differently. All right, with that said, you pause and get yourself ready. Get your notebook out. Go do it now. Ready, pause. Okay. All right. So today we're going to talk about, we're just talking about basically sciences in general. All right. The world is full of all different kinds of things and different events happening. All right. Science itself is a tool. All right. It's a method for us to understand the world around us and the universe around us. All right, just to understand the mechanics of how things work, why things work, all right, and to be able to do that, to make predictions, and in our age of technology, to manipulate certain things about that. We'll talk a little bit about that with gene editing and stuff like that during the school year in biology. All right, it's the idea of what the process that we use to do it. Now, you guys all remember growing up doing the scientific process or a scientific method. All right, that is kind of a scaled down version of it, kind of simplifies, which is very good for younger ages. The process of science can be at times very messy because you're doing a lot of things, you're getting a lot of things wrong, but it's the same ideas, same concept, same theme of how to do it. It's always about explaining a scientific phenomenon. The more complicated the theme or the phenomenon or the event, the more unknown it is, the harder this process is, and the longer it takes, and the more people it takes to work with it. All right. So we're going to start with a really, really basic one today. All right, and we're going to kind of talk about this scientific process. A lot of this being reviewed, talking about observations, variables, law, and theories. All right, we're going to pick a really simple phenomenon today. I have my four-square ball. All right, we're going to do a really simple phenomenon, and it's going to be if I hold the ball about my height and drop it, it bounces back up. Really simple one here, but let's say I wanted to create some sort of test to have a better understanding of this phenomenon. All right, first thing we need to do about this phenomena or this event is take observations. All right, and now we could take lots of observations. We could take observations about the ball, about the actual dropping. You want to take as many as you can when you start. All right, so when we're taking observations, all right. All right, observations, these are just anything that you can sense, all right? Anything that you can sense with your five senses. That's kind of the easiest way to describe it. It's how we use our five senses to explore or study the world around us. We do this from the day we're born, before we're even born, using our senses to try and observe the world to get a better understanding of it, all right? So we could use our senses, our intuition to kind of do things like this. Anything that we've learned about stuff, that's an inference. And so identifying observation versus inferences. So let's just do some simple ones. Let's start with the ball. It's a round ball, right? I'm just spitballing here. Let's see, round ball. It's a red ball. See, I measured it right beforehand. It's about 20 centimeters wide. All right, it's got a 4 on it. It says 4 square. It has the number 4 on it. Here, let's just do the number. It's got a number 4 on it. It weighs about 2 pounds, I'd say, but let's use the metric system. 2 pounds, that's not even 2 pounds, I'd say it's about a pound. So that's about half a kilogram. We'll do it over here. Makes a loud sound. Let's think about the actual phenomena itself. When I drop it, makes a loud sound. Let's see. I have a very specific place where I'm dropping it from, very specific height. So I guess a drop height, and then it comes back up, like the bounce back height. So that's 2 observations. It's got a drop height, and let's call it the bounce height, which is basically the bounce back height. All right, that's good for now. We can make lots and lots and lots of observations. If we wanted to keep going, I think that's a good place to start. All right. So now what we need to do is be more specific about observations. There's all kinds of observations we can make, but there's only a handful that we actually want to use. All right. Science, and what we need to do now is identify the difference between a qualitative observation and a quantitative observation. All right, so we have 2 different types of observations. We have the qualitative, which is more of a kind of a descriptive observation. And then we have quantitative. Which deals more with like a measurement. In the 2 different types of observations we can have. So let's go back and think about which one of these are qualitative and which one of these are qualitative and which one of these are quantitative. All right, so we have a round ball. All right, so I want you to take a second while we're going through this video as we go through each one. I want you to give it a second and think about which is it qualitative or quantitative. So is it descriptive or is it a measurement? All right, so a round ball. It's descriptive. That's going to be qualitative. All right. A red ball. That's a description. So that's a qualitative. All right. 20 centimeters wide. I have to actually take the measurement and measure how wide it is across. That's going to be a quantitative measurement. The fact that there's number 4. Now this one's tricky. A lot of people, especially early on, like to think that, well, it's got a number. That's a measurement. Is this number 4 measuring anything? I mean, it's the number of squares, but is that measuring anything? No, it's just a description. It's a description that there's a number on there. All right. So this is actually a qualitative one. Numbers do not equal quantitative. Quantitative is a measurement. All right, we're not measuring anything to see that 4. That 4 is not a result of a measurement. So that is a qualitative measurement. All right, we can go a little bit faster here. Weighs 0.5 kilograms. I'd have to use a mass or a scale to do that, or some sort of balance. So that makes that quantitative. Loud sound. I'm using my senses, but that's a description. Loud, quiet. That's a description sound, so it's qualitative. Drop height. I can actually measure that. I could even say that drop height was, it's 2 meters. We'll say the drop height, bounce back height was 1 meter. Be more specific. All right, those would make those quantitative measurements. All right, now in science, we don't want qualitative. All right, we want to be able to use quantitative because when we can use quantitative, that gives us numbers and or things that we can manipulate to test. All right, It's hard. You see a lot of what they call the pseudosciences or the soft sciences. They use a lot more qualitative measurements. Now, some of these things we can change into quantitative measurements. For example, if I have the right equipment, I could change this loud sound and turn it into, say, it gives off 150 decibels of sound. That's a measurement. Now I've turned that loud sound into a quantitative. All right. Or I could say red ball. That's actually color is a measurement of the frequency of light. I could say, well, if the red ball gives off a light wave of 350 nanometers. Now that is now a quantitative measurement. All right. So the fact that we can turn some of these into quantitative, but in the end here, I ended up with just my simple example. I ended up with four quantitative measurements. Some of them we could turn into it, but let's think about which one of those now, of those observations, which one of those we could use into to explain this phenomenon. To do this, I'm going to collect data to get a little bit more about it, and I'm going to pick two of them. All right, I'm going to pick two of them. If I want to do an experiment to collect data, you always want to collect based on two observations at a time. All right, so I'm going to pick, since I'm really seeing about the dropping of this, I'm going to pick this one. I'm going to pick this one. And these observations are now going to become, in my experiment, they're going to become my variables. A variable is anything that changes within an experiment. All right, so now I have my two variables. Again, it's anything that changes in an experiment. And I'm going to use these two observations. We should all be familiar with the two types of variables that are in an experiment. There should only be two things that change. One you call your independent, and the other one you call your dependent. Right, your independent and your dependent. All right. If I'm going to use these two observations and use them as variables, I am going to pick one of them that I change in the experiment or I cause, and we're going to see the result of the other variable. These are the only two things that should be changing. All right. So if in this case here, you could do it either way. Either one could be independent, but one's way easier than the other. I could say, well, I want to see, based on this phenomenon, how does the drop height affect how high it bounces back up? All right, that's a really easy one. I have to choose which one of those am I affecting. Am I personally choosing the drop height or the bounce height or the drop height? I always like to think about it sometimes as cause and effect. Cause and effect. It's what I cause to see what the resulting effect is. Or more definition would be the independent affects the dependent. So if I change the drop height, I'm going to affect the bounce height. So if I drop the foam up here, it's going to affect on how high it bounces back up. All right. Anything that's not the drop height and the bounce height, in this case now my independent and my dependent variables, everything else should be a constant. Constant is anything that stays the same throughout the experiment. All right. Everything else, I should be keeping the same ball. All right. But that has the same width and the same weight. I should deflate it or test it every once in a while with a different ball. I'm not testing that. I'm testing drop height and bounce height. All right. Once I do that, I can collect my data. All right. Once I collect that data, again, this is all going towards something, right? I'm trying to learn more about a phenomenon. All right. Once I get to enough testing enough of these observations, I can maybe, ideally, start to explain some of these observations. Give some sort of reasoning, some sort of final conclusion that explains everything. And that leads to basically the two conclusions of experimentation. Now, I say lots of experimentation, and that is the difference between developing a scientific theory versus a scientific law. Now, these two things are very different from each other, but they're a lot of times confused. Biggest misconception is that a theory becomes a law. That is not the case, or vice versa. That is not the case. They are different things. It's apples and oranges. All right, both are fruits, but they're different. In everyday language, we use the word theory kind of incorrectly. We say, I think that, based on the way things have been going, I theorize that remote learning, we're going to be doing more remote learning this year. I have a theory that we're going to do a lot of remote learning this year. All right. We think of it as kind of like almost kind of like a hypothesis. We're trying to kind of almost speculate what's going to happen. Scientific theory is different. Scientific theory is an explanation. All right. And what it does is it takes it's some sort of explanation of a bunch of observations. Why is this happening? This is why it's happening. This is what's happening because of it. All right. An easy example of this is the theory of germ theory. Germ theory. Germ theory is the theory that, why are all these people getting sick? Why, when one person who's sick goes around another person that's sick, or goes around other people, they also get sick. And that explanation is this idea that there is these microscopic organisms, bacteria, that spread from one organism to another and infects them. All right, that's called germ theory. All right. While scientific law is more of a description of what happens, or which allows a lot of times for predictions, what's going to happen. You see a lot of this in physics. So, for example, if I drop this ball here, at this point here, the ball is going to fall to the ground. That's describing what's happening. That's based off of the law of gravitation. Law of gravitation, the law of gravity, basically says that this ball is going to be pulled down. Is it describing or predicting what's going to happen? It does not tell me why it happens. The why is a theory. The theory is based on evidence. All right, now, that theory of why that happens, why does it fall? You say, well, it's gravity, or because it's the Earth. Why is the Earth making it fall? All right, that takes explanation. All right, that comes from testing, and in the case of this one here, extreme mathematical testing, dealing with Einstein's theory of relativity. He says that based on that, Earth is bending space-time, and that's why things are pulled down towards it. All right, that's not the point. The point is, one is a description of what's happening. The other one is an explanation of why something is happening. All right. So, for example, one theory we'll be talking a lot about this year is the theory of evolution. All right. That explains why there are different species on this planet. All right. While one thing we'll be talking about this year in biology is the law of inheritance, which basically says that you get your genes, half your genes from your mom, half from your dad. That's describing what's happening, not explaining it, just saying that's what's happening. All right. So a lot of times people will think, if I get enough evidence, can't it just become a full truth, like a law? No. All right. Theories are based, or strength are based on the amount of evidence they have. The more evidence, the stronger the theory. In fact, sometimes we get new evidence that takes a really strong theory and pokes holes in it. When I was in high school, the theory of the Big Bang Theory was kind of the predominant theory of how the universe began. There wasn't really any other ones out there. But as we develop more technology, that theory is now being pushed. In fact, the idea of the simple Big Bang Theory is actually not the predominant theory of how the universe works anymore. It's a part of it, but it's not all of it. New observations leads to new experiments, which can lead to further explanation or a change in the explanation of what happens. All right, so that's the difference. That's observations. We talked a little bit about variables and the difference between theories and laws. All right, if you weren't sure, go back and watch some of this. Otherwise, that will be good for now. All right, thanks everyone. See you later. Good luck, and may the science be with you. Bye.